Hello, and this is the Genuinely Approachable Sudoku for the 1st of February 2024. It is I'm So Sorry by Philip Newman. So, it is a ratio pair Sudoku, so let's look at the rules. Normal Sudoku rules apply, so place the digits 1 to 9 every row, every column, and every 3x3 box. Ratio pairs. Digits in cells separated by a black dot must have the ratio given. So, for example, these digits are separated by a dot with a 3 in it, so they must have a ratio 1:3. Same for this, has a ratio 1:2, this is a ratio 1:6, this is a ratio 1:9, and so on and so forth for every dot. Alright, with that, let us begin solving. Now these large numbers I think the most useful. So the 6, the 9, the 5, the 7, because for integers with large ratios, you must have 1 on one side and the number itself on the other. For example, for this 9 here, you must have 1 on one side and 9 on the other. Those are the only two digits from 1 to 9 that have a 1 to 9 ratio. And similarly, these two digits must have a 1 and a 5 in it. And so in fact, because both of these must have a 1, the 1 must be where they intersect, which is here, allowing us to place 9 and 5. Same for this 7. We can also place 1 and 7 here. And actually, we can place the 1 in the middle, because 7 doesn't form a 1:3 ratio with any other integer. So this can't be 7. That's 1, that's 7, and this must be 3 to form the 1:3 ratio. Right, now here, this 1:4 ratio cannot have a 1 in it anymore, and therefore it's only possible with 2 and 8. This set here cannot be 2 and 8, and therefore must be 1 and 4. The 1 here sees that cell, so that's 4, that's 1. This must now be 6, and that must now be 2 to make a 1:3 ratio. That must now be 1 because it can't be a 4 to make a 1:2 ratio. Cool. Right, maybe we look at this now, because again, it can't have a 1 in it, so it must be a 2, 8. This has to be a 4, right? If it's a 2, it can't be a 1, so it has to be a 4. If it's an 8, only a 4 works, so this has to be a 4 in all cases. Cool. Maybe we look at that now. That only has 3, 6 as an option, doesn't it? Because it cannot be, this ratio dot is a normal crop key dot, because a normal crop key dot has a black dot that indicates a ratio 1:2. And there are only 4 options for this 1:2 pair here. That would be 1, 2, 2, 4, 4, 8, or 3, 6. This 2 and 4 prevent 1, 2, 2, 4, and 4, 8 from all being possible. So the only final option is 3 and 6. Wait a minute. Does that work? I don't think that works. Oh no, it does. It does work on a very special condition. Because I was looking at this cell and I saw that cell. I said it can't be 1 or 2, right? But then how would it be fulfilled then? Because the 3 would need a 1 and 6 would need a 2. But that's actually incorrect, because the 3 doesn't only need a 1. The 3 can also have 9 as an option, because 3, 9 is a valid 1:3 ratio. So we can place our digits in this way. This 2 now sees that cell, so that's 8. I should have resolved that first. And those digits would be 5, 3, 5, and 7 to finish the column. Okay. That was pretty interesting. Yeah, I absolutely missed the 3, 9 here. What can we do now? I mean, I guess this 1, 5, 9 doesn't see those cells, so 1, 5, and 9 must all be in here. 1 actually can't be there, so 1 goes there. This is a 5, 9 pair as a result. And this is 7 and 8, which means that this cell can't be 8, so that's 2. That's 8. Those cells are 6, 7, and 8 as well, okay. Which means that since those cells can't be 8, 8 must go there. Those cells have to be 5, I can't read, 4, 5, and 3, 4, and 5. To complete the box, that can't be 5. And in fact, actually those two cells form a 3-4 pair. This 4, wait a minute. No, sorry, the 4 here sees that, so that's 3. Whoopsies. Which means that digit is a 6. There we go. Those digits have to be 3, 7, and 9. That's how it can be 3 or 7, so that's 9. Forms a 3-7 pair. Those digits also form a pair. I think it's a 4-5 pair. Okay. I think that might have some options. It could be 1-4 or 2-8. I don't think we can... It can't be 1-4 because 1 and 4 both see that cell. So it can't be a 1-4 pair, otherwise that would have no option. So it must be a 2-8 pair, and this 2 resolves that. So 8, 2, 8 must be next to 4. 2 here could be next to 4 or 1, but it can't be next to 4 because of that, so it's next to 1, which is also next to 3. I guess because of this 3 dot, it can't be next to 4 either way, so... Fair enough. Okay. This 8 sees that cell, so that's 7. That's 8. This cell can no longer have a 7 in it. I think this does have options though. It can't be 3, 6, and it can't be 4, 8. It could be 1, 2, or 4. This can't be 4. Actually, the 1, 2 here means that's a 4, which must be next to 2. So there we go. Here we have 5, 7, and 8 as well. That cell can be 7 or 8, so that's 5. No, not 5, 7, 8. What am I doing? 1, 5, and 7. That cell can be 7. Alright, fair enough. Nothing much here. 6. I think this has to be a 4, 8 because it can't be 3, 6 because of that. It can't be 1 or 2 either. So it just has to be 4 and 8. So that is no longer 4. Those digits have to be 3 and 7 to complete the row, which we can place. I think 4, 8 here does push some digits here. This is an 8, this is a 4. If this is a 4, this has to be a 2 or an 8, but it can't be an 8. So this is either 2 or 4, I think. Yeah, going through the options one by one. Not sure if that's very efficient, but I think that's what I'll do. This must be 5, 7, and 9. That can't be 5. I don't think there's much else to do though. Oh, 3 here means that's not 3. What's the last digit we're missing in this box? 8, right. 8 can't be there, there, or there, so 8 goes there. This is now 5, 7, or 9 as well. Cool. I think we haven't used those dots yet, so we might use that. This is 1, 3, 3, 6, or 3... No, not 3, 6. It was 1, 3, 2, 6, or 3, 9. Can't be 2, 6, but it could be any other thing, I think. So... No, I don't think that... Wow, okay. I guess we are just missing something then. Are we? 8... 8 maybe. 8 can't be in those cells. This 8 means 8 can't be there, so in this column 8 can only be there. Oh, so 8 sees that, so that's 4. That's 8, which must be next to 4. Okay, that resolves a lot. That's 4, that's 5. Oh, the other way around. This cell now can't be 8, 4, 8 or 2, 4. Could it be 2... Could it be 1, 2? No, because 2 in those cells see both of those cells. So it can't be 1, 2. Maybe it must be 3, 6, which we can resolve. 3 here, 6 there. This 3 means it's either 1 or 9. Gotta remember that it could be 9 as well, although we can't resolve that. We need a 6 in this box. We don't know where it goes. How would we know where it goes? Oh, we'll know where it goes by the second digit in this set of 2, I guess. 6 means that's now 7, so that's 6. 7 is not there, forming a 5, 9 pair in this row. Right. This 5 means that's no longer 5. We need a 2 in this column. We don't know where that would be. Weird. Okay. Not a lot of things to go by. 3 means that can't be 3. So 3 in this column can now only be there. I think we can finish up all the 3s then. Yeah, 3 in this box must be there, which resolves this 3-7 pair. That's no longer 7. I think that forms a triple of some sort. 259. 259 triple. That can be 2 or 5, so it's 9. That's 5, that's 2. 5, so 5 can't be there. Forms a 7-9 pair. Also a chocolate teapot, which is very nice. This is 7 or 9 as well. Those digits have to be 2 and 6, and 2 here means 2 can't be there. 2 can't be there, so 2 is there. Oops. This is 1, 7 or 9 to finish the column. Alright, I think we're almost done here. Just a lot of 5, 7s and 9s to get over with. Yeah, this dot is technically resolved because no matter what you put in here, it's fine. Oh, this cell. Why didn't I see that? I think that's a 5. 5, 7, 9, 5, 9. This is no longer 7 or 9, so that's 1. That's 2. 1 resolves this entire thing here. This 9 resolves this 5-9 pair. 5, 9. Sorry, this is 1, 5, 6. Yeah, this is 1 and 6, I think. Which we can't resolve. Wow. And this is 5, 6, and 7. 5 actually sees that, so I can resolve that, which means I can resolve this. This is now a 6. This is a 5, 7 pair, which we can resolve. 7, 5. This 7 resolves the 7, 9 pair to finish the puzzle. Solved in 10 minutes. Well, 11 minutes, but close enough. Alright, hope you enjoyed that puzzle. I'll see you next time. Bye bye.